So in this video, let's talk about integration by trigonometric substitution, integration by partial fractions, and the definite integral. So first, let's start integration by trigonometric substitution. So whenever you see an expression that has a form of x squared plus a squared somewhere in it, you want to replace x with any tangent theta. But if you see an expression x squared minus a squared, then replace x with a secant theta. But if you see an expression a squared minus x squared, replace x with a sine theta. So let's try an example. So let's find the antiderivative of 1 divided by x squared times the square root of x squared plus 9 dx. So you notice that we have the form x squared plus a squared in this expression. So therefore, we can say that a squared is equal to 9, which means that a is equal to 3. And said that if we have the form x squared plus a squared, so we want to replace x with a tan theta. So therefore, we're going to replace it with 3 tangent theta. So if x is equal to 3 tangent theta, what is dx? So dx is the derivative of the tangent, which is 3 secant squared theta d theta. Now, what about the x squared? If x is equal to 3 tangent theta, so our x squared is equal to 9 tangent squared theta. So at this point, let's replace x squared with 9 tangent squared theta. And also, the inside the radical, we have 9 tangent squared theta plus 9. So now let's replace the dx. So let's multiply everything by 3 secant squared theta d theta. We have 3 secant squared theta d theta on top. On the bottom, we have 9 tangent squared theta and the square root of 9 times the tangent squared theta plus 1. So we can divide the 3 and 9. So we have a secant squared theta d theta on top, and we have 3 tangent squared theta times the square root of 9 secant squared theta, where tangent squared theta plus 1 is equal to secant squared theta. So we have secant squared theta d theta over 9 tangent squared theta times sec theta, where the square root of 9 sec squared theta is 3 sec theta. So both top and bottom we have sec theta, so we can cancel the secant theta. So now we have secant theta d theta over 9 tangent squared theta, so we can eliminate the constant from the integral. So we have 1 over 9 integral of secant theta over tan squared theta d theta. So this time we need to convert secant and tangent into sine and cosine. So let's rewrite it first. So we have integral of secant theta times 1 over tangent squared theta d theta. So secant theta is equal to 1 over cosine. It's a reciprocal identity of cosine. Then tangent is sine over cosine. So tangent squared theta, sine squared theta over cosine squared theta. So 1 over tangent squared theta is equal to cosine squared theta over sine squared theta d theta. So we can cancel the cosine theta. So now we have 1 over 9 integral of cosine theta d theta over sine squared theta. So now we need to do another substitution, particularly use substitution. So let's set the u variable is equal to sine theta. So our du is equal to cosine theta d theta. So our d theta is equal to du over cosine theta. We have 1 over 9 integral of cosine theta over u squared times d theta, which is du over cosine theta. So we can cancel cosine theta, so we have 1 over 9 integral of du over u squared. Then let's put u squared on top. So 1 over 9 integral of u to the negative 2 du. Let's add 1 to the u to the negative 2. So negative 2 plus 1 over negative 2 plus 1. So we have 1 times u to the negative 1 over negative 1 plus c. So let's rewrite the equation. So we have negative 1 over 9 times u plus c. So let's remove the u variable back to what is it. So u is equal to sine. Therefore, we have negative 1 over 9 sine theta plus c. Since our goal is to get it back into the original variable, which is x. So we all know that x is equal to 3 tangent theta. So what is sine? In this case, let's solve for tangent theta. If x is equal to 3 tangent theta, so tangent theta is x divided by 3. And then let's make a right triangle. We all know that tangent theta is equal to opposite side over adjacent side. So the opposite side is x and the adjacent side is 3. So using the Pythagorean theorem, which is a squared plus b squared equals c squared, we need to find the hypotenuse. So we have a squared is equal to 3 squared plus our b squared is equal to x squared. So let's take a square root on both sides. So we have square root of 9 plus x squared equals c. So since we figure out the 3 sides of the triangle, so we can figure out what is the sine theta is equal to. So according to SOHCAHTOA, sine is equal to the opposite over the hypotenuse. So let's go back to our right triangle. So the opposite of is the x and the hypotenuse is square root of x squared plus 9. So now that we know the value of sine, all we need to do is replace sine. So we have negative 1 over 9 times the square root of x squared plus 9 divided by x plus c. So the final answer is negative the square root of x squared plus 9 over 9 times x plus c. So next is the integration by partial fraction. So let's have an example. The integral of dx over x squared minus 9. First, set aside the dx and the integral sign. So we have 1 over x squared minus 9. And if we're going to decompose this into partial fraction, that is simply equal to a over x plus 3 plus b over x minus 3. Because x squared minus 9, if we factor out this, would be equal to x plus 3 and x minus 3. So now that we have this partial fraction, which is a over x plus 3 plus b over x minus 3. So now let's going to solve for the values of this constant a and b. So in order to do that, let's multiply the factored values to the partial fraction, which is a over x plus 3 and b over x minus 3. So we have a times x plus 3 times x minus 3 over x plus 3 plus b x plus 3 times x minus 3 over x minus 3. So as you can see, we can cancel out the x plus 3 and x minus 3. So it turns out that 1 is equal to a times x minus 3 plus b times x plus 3. So let's do distribution, the a and b. So ax
minus 3a
plus bx plus 3b. Then let's combine like terms. So ax plus bx plus 3b minus 3a. So now let's try to find the value of a and b. So let's factor the x. So we have a plus b times x plus 3b minus 3a. So we have the two unknown here. The first equation is a plus b is equal to 0 because we have an x on the right side but we don't have x on the left side, so the answer is 0. So if we manipulate, so we have a is equal to negative b, that is our first equation. So the second equation should be 3b minus 3a equal to the constant 1 because there is no x in this term. Then we can insert the first equation to the second equation. So we have 3b minus 3 times negative b is equal to 1. So negative times negative is positive. So it became positive 3b. So 3b plus 3b is 6b equal to 1. So let's divide both sides with 6 since we find the value of b. So it became b is equal to 1 over 6. So a is equal to negative b. So the value of a is negative 1, 6. So these are the value of our a and b. So now that we are already know the value of our a and b, so definitely we need to go back to our equation, which is a over x plus 3 plus b over x minus 3. So we have the integral of a dx over x plus 3 plus the integral of b dx over x minus 3. So let's substitute the value of a and b. So we have the integral of a, which is negative 1 over 6 dx over x plus 3, plus the integral of b, which is 1 over 6 dx over x plus minus 3. Then let's put the constant outside of the integral. So we have negative 1 over 6 integral of dx over x plus 3 plus 1 over 6 the integral of dx over x minus 3. Then we evaluate the integral of the equation. So we have negative 1 over 6. So dx over x plus 3 is equal to ln absolute value of x plus 3 plus 1 over 6. So dx over x minus 3 is equal to ln absolute value of x minus 3 plus c. So the answer is negative 1 over 6 ln absolute value of x plus 3 plus 1 over 6 ln the absolute value of x minus 3 plus c. Next is the definite integral. So let's have an example. Let's find the area under the curve of the function f of x equals x plus 5 dx within the area from 0 to 4. If we translate the word problem into integral notation, this would be its form. So the definite integral is from 0 to 4 of x plus 5 dx. Now, we need to find the integral of x plus 5. So let's use the antiderivative. So the integral of x is x squared all over 2 plus the integral of 5, which is 5x, with the interval of 0 to 4. So now, let's substitute the upper limit to x minus the function substituted by the lower limit. So we have 4 squared over 2 plus 5 times 4 minus the lower limit, which is 0 squared over 2 plus 5 times 0. So let's simplify. So we have 16 over 2 plus 20. Then we can simplify the 16 over 2, so it became 8 plus 20. So the area under the curve of the function f of x equals x plus 5 dx on 0 to 4 is 28 units squared.